We're going to look at another related rates problem. So this is pretty similar to the last problem, but with some important differences. So I left some of the structure up here. So we have another spherical balloon. This time it's being inflated so that the volume is increasing. All right, so we've got some information here about volume and about a rate of change. This time, since the volume is increasing, that's a positive 3 cubic centimeters per minute. Positive because it's increasing. And we're supposed to find the rate at which the radius of the balloon is changing. So that's what we're supposed to find. And the other information that we're given is that we're interested in finding this out when the volume is 100 pi cubic centimeters. Okay, so one important difference between this and the last problem was that we have a positive rate of change here, so just paying attention to that. There'll be a little bit of other difference as we get into working out the problem actually as well. So, okay, and we would want to find an equation that relates the variables. So we have here the same equation we used before for volume of a sphere. So we're going to start with that equation that relates those variables. On these related rate problems, next step is always going to be to differentiate implicitly with respect to time. Okay, so on the left side of the equation, we'll have dv dt. On the right side, implicit differentiation again. So 4/3 times 3 will be 4 pi r squared, and then times dr dt. We're treating r as a function of t. And so then on the last problem, we were able to just plug in the numbers at that point and find out what we were asked to find out. So the dr dt is what we're being asked to find. We're given dv dt, so we're going to put positive 3 in place of that. But there's a little bit more information. We're given this information about volume, and we need actually a number to plug in for r. So before we can finish this problem, we do have to do a little bit of extra work here. I need to find r when v is 100 pi in order to answer this problem and find the dr dt that we're being asked to find. So let me go back over here to my original setup here, and sometimes you need to know all of the different variables and values for those and rates of change to start the problem, and sometimes you don't. So I wouldn't get worried about filling all of these in unless you're going to need them in the problem. In the last problem, we didn't need information about all of these to find those values. So we need to find r when v is 100 pi. So we're just going to solve this for r. We might notice that there's a pi that I can divide into both sides and then multiply both sides by 3/4. So I'm just going to do a little bit of algebra there. If I multiply by 3/4 and divide by pi, I'll get 75 equals r cubed. So our r will be cube root of 75. And that's what we're going to use here for our r when we solve this problem. Okay, so now that I had to do that little bit of extra work there to find my r when v was 100 pi, now we can go ahead and finish this problem, remembering that we're ultimately interested in finding dr dt. Okay, so dv dt, we're going to put in 3 for that. 4 pi. Our r was cube root of 75. And that's going to be squared. And we're supposed to find dr dt. So from here, it's just a matter of solving for dr dt, so I'm going to just divide through by this constant. And then it's a matter of how much you want to clean that up. I'm going to just leave it in that form. I'm going to go ahead and label my answer. Again, paying attention to the units on this rate of change that we're trying to find. R is a radius. That's going to be measured in centimeters here, since our volume's in cubic centimeters. T is time. That's going to be measured in minutes. So this is a rate of change, centimeters per minute. If I want a decimal approximation for that, fine. We can plug that into your calculator and you'll get that. I think you get about 0.0134. Okay, but exact form answer here. Don't forget the label. Centimeters per minute. Okay, we'll look at some other examples using some other shapes besides spheres as well.